All right, in this section, we're going to be talking about some different types of statistical graphics, and we're going to be talking about also the pitfalls that you can encounter. So to start off, I'm going to be talking about best practices for statistical graphics. So just as a reminder, there are two different types of variables that we typically are dealing with, continuous and categorical variables. And different plots are designed to represent specific types of variables. And so in the subsequent lessons, we're going to be walking through this. And there are three characteristics of a good statistical graphic. The first is that it reveals the structure of the data. The second is that it actually shows the data itself. And the third is that the graph is properly scaled. Okay, so revealing the structure. Good graphs reveal structure, as opposed to summary measures or summary statistics, which really don't reveal the full structure of the data. So remember in the Table 1 section when we talked about the closed randomized controlled trial, and we showed this piece of the Table 1. Here, summary measures are given for each of the different baseline characteristics. For example, we can look at the mean or the median, and these numbers can be helpful to better understand the characteristics, and it would be cumbersome to look at a graph of every single one of them, so summary measures are definitely useful. But they don't fully reveal the distribution or the shape or the structure of these variables. So for example, let's take age. We see here that the mean of age in the standard care group is 5. But what happens if we try to plot that? Let's say, for example, that we plotted age and this is what we saw for the distribution or the shape of age in this cohort. So here, the mean might still be 5, but that's essentially a useless measure because that's where the least amount of data are. So we're going to get into how to interpret this type of graph in the subsequent lessons, but just to kind of show you what I mean by structure of the data. Okay, so good graphs reveal structure, and good graphs show data. Okay, so what I mean by that is here's a plot known as a dynamite plot, and this plot is notorious for hiding data. So just from looking at this, it's hard to know if the data are skewed, it's hard to know the sample size, and we can overlay those points and see what I mean when I'm talking about this graph being a little bit misleading. So now I've added the actual data points, and just looking at that first bar, you can see the first and second bar don't look that different, but the first bar is based on only 5 data points, and we would never have known that if I hadn't overlaid the data itself. So a good graph shows the data. And finally, a good graph is properly scaled. Okay, so here's some data. Notice the scale here is from 0 to 160 on that vertical axis or the y-axis. So that's the true scale for this data. But what if I plotted it like this? These are the same data points, but I've changed the scale to be from 0 to 5,000. So by stretching the scale, I totally distorted the shape of that data, of what it actually looks like. And now it looks almost like a flat line. Whereas previously we saw it looked like it was not a flat line at all. It looks like, there's some relationship there. Here's another example. In addition to scale, it's important to take note of where the graph begins. And so in this plot, it ranges from 94 to 100. And on this scale, the 2 point ranges that I've plotted look pretty different. But suppose that for these measurements, an appropriate starting value is actually 0. And so when we look at that, these point ranges actually no longer look that different at all. Starting at 0, these look like they're pretty similar. So having an appropriate start and an appropriate scale is really important for having a graph that's not too misleading. So these are the key pieces that we want for a good statistical graphic. And not all of the plots that you're going to find in the medical literature are going to follow these conventions. But it's important to keep them in mind when you're interpreting presented results. So in the following sections, we're going to be discussing 5 different types of plots: histograms, box plots, dynamite plots, scatter plots, and forest plots. So these are all types of plots that are really commonly seen in the medical literature. So we're going to go through them, how they're often used, how to interpret them, and then finally we'll address some potential pitfalls that you can encounter with each of them.